In this video, we're going to take all that we've learned in the past couple of videos and put it all together and come up with a really useful, scalable, robust algorithm for doing calculations, in this case, the average. The tool that we're going to learn, the new thing we're going to learn is called the loop. So we're going to learn about loops here. Just as before, we're going to do a command prompt. We're going to bring up the command prompt, CMD in the search, click on it, open it up, CD desktop, CDC code, and then we're going to make a new project. Make project.bat space average underscore v2c, the final one, the final edition of version 2 of calculating the average. And then up comes, then we can, in File Manager, we can click on that folder that we've made and then click on average v2c. And up comes Notepad++. We take the previous version, the average v2b on the left tab, Control A, Control C, and then go to the right tab that has average v2c on it, Control A, Control V, and then we have the old version in the new version, so we're starting from that version, not from hello.c, same as before. Okay, here's the big new thing. What I'm first going to introduce is called a while loop. It's a loop. A loop structure is do everything inside of the curly braces. So there's a left curly brace you'll see and a right curly brace you'll see. Do everything inside there as long as the condition that is inside the while loop is true. As long as I is less than 3. 0 is less than 3, 1 is less than 3, 2 is less than 3. Those first 3 elements of the array, do whatever's inside that loop. That's what a loop does. And so this new structure is a really powerful tool for all kinds of programming languages, and C is one of those. So I didn't really reinvent the wheel here. I'm still using the line sum equals sum plus a sub I and I equals I plus 1. Right? I'm doing I equals I plus 1 after I add the sum, so that by the end of this while loop, on the first round, I added a sub 0, but I has a value of 1 for the next round coming in. So that's how that works. I've made sure before, and just like with every loop structure, you always want to make sure that sum equals 0 and that I equals 0 at the top. You can see way at the top there that they've been assigned the values of 0 before they enter the loop. And then there are 2 different printf statements. There's a printf statement right after I initialize sum and I to be 0, so that's important just to double check that. And then I added a new print line saying, okay, the next printf statements that you're going to see are inside the loop. There's only one of them, but you're going to see it happen 3 times because it's going to loop through 3 times. So that's what's going to show up on when I compile and run this program. And lo and behold, you can see when I compile and execute the program, you can see the printf statement at the beginning, sum equals 0, I equals 0. And then there's the tell statement inside the loop, and then you see the 3 printed statements there where sum equals 3 and I equals 0, and then you increment after that printf statement, so that's why you see I equals 0 still within the first loop, and so on. And so you can see the same exact thing happening whether we printed it before in version 2b, when we had a big long, we just have a bunch of different sum equals sum plus and a bunch of printf statements. Here, we only have 3 sum equals sum plus a sub I statement, 1 sum equals sum plus a sub I statement, and 1 I equals I plus statement, and 1 printf statement, but it happens 3 times because it's in this while loop. Cool, super cool. You'll notice at the bottom of the command prompt little section there that I ran it again. What I did was I took out all the printf statements, the diagnostic printf statements. Now that we can see how a loop works, I'm going to take them out to sort of simplify and just prove that the program works now that you've seen it once. The next little thing to learn is the ++ command. So with integers like I, you can instead of saying I equals I plus 1, there's a shorthand way of doing that, saying I plus plus. And so that's in all of C. Any integer you can increment by 1 just by saying I plus plus if it's the integer I. Another smarmy thing about C programmers is the second generation of the C programming language is called C++. It's one increment above C. And so that's the smarmy C++, C way of saying we're going to increment the language by 1. A lot of advanced programmers who might be watching this, who might be using this as an educational tool for other people, they might go, why is he bringing up a while loop? It's true, not many people use the while loop. There's a special case of the while loop. When you start at 0, you increment by 1, and you go through and you're testing for a condition of I less than something. That's called a for loop. And I'm showing that here. And so what I'm going to say in English what a for loop is. The first, there are 3 statements inside the for loop. There's I equals 0, then a semicolon, then I less than 3, semicolon, then I plus plus. And so the for loop's saying, okay, start at 0. As long as I is less than 3, go through the loop, and then at the end of the loop, increment I by 1. That's how to say the for loop. It's exactly the same as the while loop that I just showed. It's the exact same functionality of it. It's just a shorthand way to do it. And so for loop is really the way a lot of technical programming does looping structures. The while loop's important. Sometimes we use while for a lot of things, but for loop is really, really common for this kind of calculation. Okay, the for loop works the same way as the while loop. You compile and run it, it'll work the same, no problem. But now, a little lesson about what we just did. What we did was we made a much more robust summing average algorithm. If we had to take the average of 5 numbers, the original way, we would have had to add D, and had to add E, and then it set E equal to something, and then D equals something, and then E equals something, and then we had to go down to the average program and say average equals A plus B sub C plus D equals E, and then divided by 5. It's just crazy, right? That's a lot more things. If you can imagine 50 numbers or way more numbers, man, that's unacceptably unscalable. It just can't happen. AA equals 28. AB equals 27. AC equals 30. I mean, it's just a crazy, it would be a crazy number of variables. So the array simplifies it, saying, okay, we're going to have so many numbers, and A is going to have all of those numbers in them, and the index is going to scroll through the column of numbers that you have. That's one way that makes this algorithm more scalable. The second thing is that the average equation would be different. How many times you have to add the sum would be different. Without the looping structure, it would be also extraordinarily onerous and easily you'd make a mistake. You'd miss one row accidentally and stuff like that. It'd be really hard to troubleshoot. It wouldn't be a very good algorithm at all. But with a loop structure, the only thing you have to change is just when it ends. So here is what I'm going to show you now is I changed it to add 5 numbers, not 3. And so in the up, I declared A as to be a 5-element array. I assigned those values at the beginning. And then I did the for loop, and all I had to change was I less than 5, not I less than 3. And in the average equation, I said sum divided by 5, not sum divided by 3. You can imagine a variable. I'll call the variable n, and set n equal to 5, and put that in there. And then then I don't even have to change those lines of code at all, regardless of how big or small, how many or how few numbers I want to take the average of. This means this algorithm is a scalable algorithm. We could do 3 numbers or 5, or what I'm going to show you is we can do 5 million numbers. You cannot do it with all these other ways that we've learned, all these simple kind of ad hoc ways that we've learned. That's the power of programming, and that's the power of algorithms and algorithmic tools like loops. It was a long journey, these 3 lessons, and it seemed I know it seems a little bit boring. I'm going off on all these tangents. But when we look back, when you go back and watch the videos again, you'll see, wow, we did learn a lot. There was a lot of information packed in all of those videos. Write all those details down and put them in your notes so that you have them and that you can so that we can use all that information that we've learned going forward.